Hello, everyone, and welcome back to Quantitative Reasoning M150 Mathematics. In the previous video, we studied deductive reasoning with a valid deductive argument. True premises essentially guarantee the conclusion. Again, if you have a valid deductive argument, true premises will absolutely guarantee the conclusion. And today we're going to look at another type of human reasoning that we call inductive reasoning, and we're going to evaluate evidence as well. The thing is with inductive reasoning, inductive is essentially evidence can make a conclusion more likely, but it does not guarantee certainty. So let's get into the examples so that we can put these definitions and terms into practice. Okay. So the first example, identify inductive reasoning. Suppose a poll surveys 1,200 randomly selected voters and finds 54% support for a proposal. Explain why the conclusion about all voters is inductive rather than deductive. Okay. So the researchers then make a conclusion about all voters. All right. So we have 1,200 randomly selected voters and finds 54% support a proposal. Okay. So 1,200 randomly selected voters and finds that 54% are for a proposal. Okay. So why is this why is this inductive? Um, because they observed only a sample. Okay. So a poll of 1,200 randomly selected voters, well, this is just a sample of the people. So we would say N is equal to the 1,200 voters, okay, or the 1,200 randomly selected voters. And but what they're doing is they're observing only a sample and are using that sample to make an inference about a much larger population. Okay. So this is called inductive reasoning. So they've taken this small sample and now they're generalizing the entire population. You can't do that. Say, for example, we went to the pediatrician recently and they're like, oh, well, your children are in the 50th percentile in this category, 40th percentile in this category. And I said, well, how many people are being selected in that sample size? They were like, well, only 100 kids. So really that 40%, if they took all children, they might very well be in the 80th percentile. Who knows, right? So they're essentially taking only this group and then saying that, oh, well, based on the people that we've collected, it means this. Okay. So again, we know that, a sample is a part of the population, right? We know that, right? But the sample provides evidence about this, right? But it does not mathematically guarantee that exactly 54% of every voter is going to support this proposal. So this is called an inductive conclusion. Okay. So this is an inductive conclusion, right? Example number two, evaluate sample quality. So suppose a website asks its own readers, do you trust the media? Right? Right. That's essentially what's happening here. Do you trust the media? And then uses those responses to make a claim about the entire public, right? Explain how voluntary response can weaken an inference about the entire public, right? So the people who choose to respond may be different from people who do not respond at all. Also, the website's audience may not represent the entire population. This is a voluntary response sample. Okay. Okay. It's a voluntary response sample. So even if we say, for example, let's say for example 10,000 people. What if 10,000 people, right, respond? The important question is not simply, how large is the group of people that responded? We also need to ask, how was this population actually selected, right? Because a large biased sample can still produce a weak conclusion. Okay, that's the idea. All right, the next problem is compare anecdote and systematic evidence. One person reports a severe side effect while a large control study reports the overall rate. Explain which evidence best supports a population claim and why. Okay, so again, suppose one person reports experiencing a severe side effect from a medication, let's say Advil, Tylenol. One person now. At the same time, a large control study reports the overall rate of that side effect. Which one gives a stronger evidence about the population? Well, the large the large controlled study group. Why? Because one person represents n equals 100, and that person, or excuse me, n equals 1. So that person's experience may be completely real, right? One person says, "Well, I've when I took that, or when I ate, let's just say, when I ate lettuce, I had a rash that accumulated on my skin." And then they make a broad deduction and say, "Well, we should not eat lettuce at all," right? People do that all the time online. Right. One person saying they have a severe side effect, and a large control study reports the overall rate. Well, which group are you going to believe more, or which evidence better supports a population claim, meaning that it's going to affect the entire population? Well, it obviously be the large controlled study group. Okay. If a controlled study group has thousands of participants, it's going to give us a much more systematic information about the overall rate. Okay. So this is essentially anecdote is not equivalent to the population rate. Okay. Now there are, again, this one person who had a severe side effect that may be very real, right? But we got to be careful not to draw expansive conclusions from one particular incident. Right. Let's continue. Example number 3. This is how to assess a prediction. Suppose a model completely predicted 4 out of the last 5 elections. So its observed success rate is essentially, 4 out of 5, which would be 0.80 times 100%. That is an 80% success rate, which is very, very high. Can we conclude that it will accurately predict the next election? The answer is, not necessarily. I would say not yet, right? That even though that's a very high rate, right? That model seems to be very successful. We wouldn't say that it would necessarily predict it. Why would we want to know things such as, were these 5 elections similar? You know, um, how many elections has the model been tested on overall? Were the predictions made before the outcomes were known? How would the model perform compared to other models? Were any predictions omitted? So the result 4 out of 5 is evidence. Okay. So four out of five is evidence, but not the conclusion. Okay. So it's just like you're an attorney. You want to take in that evidence. Yeah, that's evidence. That's great. It's an 80% success rate. We're going to take that into consideration, but we still have more work to do. We still have to test it on other elections. We still have to test it. Does the model perform compare, how does it compare to other models? You know, are there other models out there? There's a lot of questions you can ask yourself. Um, and so we don't want to make a conclusion, even though it has a very high success rate. All right, example number 4. This is how to compare weak and strong or strong and weak inductions. Okay, suppose we want to know what voters across a state believe. Okay, decide which better supports a statewide conclusion and identify remaining uncertainty. Okay, so for example, let's say, all right, I'm gonna call, let's say method A, right? Method A, we use a random statewide sample. Okay, method A, we use a statewide, a random statewide sample, and then method B, we interview people attending, you know, one political rally. Okay, which gives stronger evidence about the whole state? Right? Would it be to use a random statewide sample, or would it be to interview people attending one political party? Right. So obviously, method A, right? Method A, you have the statewide random sample is more likely to include people from different backgrounds and opinions, right? Those people, you know, you might get, you know, people who are, uh, you know, upper class, middle class, low class, whatever, based on economics, because obviously the classism is ridiculous, but nevertheless, it would be a contextual factor. You would get more, maybe more of a demographic spread. You would get maybe a range of political views, a range of registered voters. Whereas, you know, let's just say you go to a No Kings rally. Well, No Kings is a representative of the Republican Party. So you would only get their worldview, and those political parties tend to be extremely biased towards their view is the right one, and everybody else is wrong. So you got to be careful taking a sample based on political bias or just any bias in that regard. Okay. Common mistake: induction does not guarantee certainty. Okay, a student says a strong inductive argument proves its conclusion. Correct the statement and explain how new evidence can change an inductive judgment. Okay, so the student thinks that an inductive argument proves its conclusion, which is incorrect. But you know, here's the thing: a strong inductive argument means the evidence gives the conclusion. Okay, uh, what it does is it gives it substantial support. Okay, so evidence gives induction substantial support. Okay, a strong inductive argument essentially means that the evidence is going to give um, the induction style of argument substantial support. That's all. But it does not mean, but not 100% certainty. That's the big idea. Because some people feel like when they argue from an inductive standpoint, all right, look, I've given you the evidence. Boom, boom, boom. I'll give you 10 precepts or 10 premises, and I'll give you a conclusion. And they're like, all right, case closed. Well, it may give you, you know, substantial support, but it does not reflect 100% certainty, because if you can find one premise that would alter it, well, there's your argument. Okay, so you got to be very careful. Deduction, you know, is essentially must follow. Induction is probably follows. Okay, so again, deduction must follow. Induction probably. Okay, that's the difference. So just remember, when you're looking at inductive reasoning uses evidence to move from what we observe toward a broader conclusion. So always ask, how large was the sample? But most importantly, how was the sample selected? And then remember, strong evidence is not absolute certainty. Okay. In the next video, you'll use these reasoning skills to identify common fallacies in the media and in politics. And again, thank you for watching.